Hi friends, welcome back. Naji here. So we have discussed a lot of things with respect to LangChain. We discussed about runnables, loaders, splitters, retrievers, then vector store, all those things that we have discussed, right? Then in this video, we are going to discuss how can we make use of all those things and how can we create a RAG application. So initially, we will be creating a notebook to do the RAG. Then we will be creating or we will be converting that into REST application or REST framework or REST API. Okay, so that's it, and we'll again just to give a overview. So RAG application, there are two part. One is data injection part, and in which we'll be loading the document, splitting the document, and we are creating embedders with respect to this splitted document. Then we will be saving to vector store. Then we will have a retriever and generator. So retriever will retrieve the document based on this question that we have that the user has given. Then we will be using a prompt, and the prompt will be given to the LLM model. Then LLM model will create the answer. So this is what we are going to implement, and how we are going to achieve this. So we will have a two pipeline. One is data injection pipeline and other one is generator pipeline. So in data ingestion pipeline, we will have a two vectors. We will have a Chroma and we will be using the BM25. Okay, so we'll see. First we will see how can we complete with the data injection, then we will go to the generator part. Okay, so here I have my notebook is ready. I have my Visual Studio Code is open, and let me create a environment. For that I will create a conda create -p env python is equal to 3.11 -y. Okay, so let me create an environment. So it is in progress, and you can see that I have added a requirement.txt file. Here I have a LangChain text splitters are added. Then I have a LangChain Chroma and rank BM25 is there. And all those things in all those packages, I have added the version number also. So it is a good practice to have the version number. Otherwise, what happens is that whenever a new version is released, it may not be compatible with the older versions. Then it will cause our application will behave like in an unwanted way, or it will break. The new releases will break our application. Okay, so we can see how this is done. Okay, so now this is done. Now I can use conda activate env no, conda activate env. Okay, let me see. Okay, we have our conda here. So let me type conda activate env. Okay, so it's activated. Let me clear it. So we can see that we have a requirement.txt file. Now I can do pip install -r requirement.txt file. So this will run our requirement.txt file. Okay, now what we can do here in between, like I'm going to create a folder. I'm going to create a folder that is called tryouts. Here I will be creating a notebook file rack1 ipynb. Let me add few cells. Let me check the status. Okay, so this is in progress. Good. Okay, it may take some time, but in between I don't want to waste time. So let me go and select the environment. I'm going to select Python 3.11. Okay, so this is my environment. Now let me test it. No, I need to install IPY kernel package also. So let me install that too. Okay, so multiple installations are in progress. Okay, here we have done the installation with the requirement.txt file is completed, and once this IPY kernel is done, we will able to write the code. Okay. Okay, so let it complete. We can import few things, right? We can have a from typings. I can import list, then I can import tuple, and I can import dict. So this is success. Okay, now we are good. Now what I can do, I can import few things from LangChain underscore community dot document loaders import py-pdf loader. I'm just checking why the okay, this is not correct. Why this is not working? So let me check this. LangChain underscore community. Okay, so since we install the environment, I may have to restart this kernel. Let me try this. No. So let me close and start it again, then we'll join. Okay, so somehow this the autocomplete is not working, so it may be little hard to work without the autocomplete. Okay, just wait. Okay, so the reason behind the LangChain community.document loader was not initially loading. So it was because like my mistake, I forgot to add that in the requirement.txt file. So I have added LangChain community in the requirement.txt file, and I have executed it. Okay, so I have executed and this is properly done. Now we will able to load the py-pdf loader. Okay. So the py-pdf loader will help us to load the PDF files. Okay. Now we can import few more things. LangChain next is LangChain community, LangChain text loader. We can have. We already have a text splitters. I can import recursive character text splitter. Now we can have a LangChain Chroma, and we can import Chroma. Now we can have a LangChain.retrievers. We can import BM25 Retriever. Okay, some syntax error. It's import import Chroma and recursive character splitter. Cannot import recursive character splitter since the autocomplete is not working. Recursive character text splitter from LangChain. Okay, so now we have let me reset again. So we have done with our imports. Now what we can do, we can create a data injection pipeline. So for that, what I am going to do, I am going to create a class, and here we will be using a data injection pipeline. Here we can have a init, and here I am going to pass the chunk size. Chunk size for the time being I am going to set it as a 2000, and which will be return none. I can set chunk size as chunk size self.text splitters. We can have a recursive character text splitter and we have a chunk size which is equal to self dot chunk size, and here I'm going to make it chunk overlap. I'm going little fast because all those things we have discussed. Okay, chunk overlap is equal to 1000. Now what we can do, we can have a self dot embeddings. Okay, here we need to have a Olama embedding. For that, what I can do, I can have a from LangChain underscore Olama. Okay, so this also I have to install. Okay, for that I can import Olama also. So let me go to the recommend text file. Here I'm going to have LangChain. I can have a Olama, and let me maybe its version which is equal to 0.2.2 is this version. Okay, now we can execute it again. So execution is progress, it's done. Now I can import Olama from LangChain.Olama, LangChain underscore Olama. I can import Olama embeddings. So here we are going to use Olama embeddings 5.3. Model is PHI3. Okay. So we are good with the init. Now what we can do, we can have a process function, process document. This process document will get a document, okay, and this will return a list. Okay, now it will create a chunks. So chunks will be text dot. We will be using the text splitters and dot split document. Then we can pass our document. So document will be in the list format. Then I can return the chunks. It's very simple function. Now what we can do, I can create a inject function. So inject function, I will be passing a string, I mean a path in the form of a string, and I will be returning a tuple. This tuple containing, okay, Chroma. One is type of Chroma, then we will have a BM25Retriever. So this is what we are going to retrieve. Now we can create a loader. We will be using a PyPDF loader, and this is the path of the PyPDF loader. Then I can load the loader. Okay, once the document is loaded, I can create the chunks. So first let me have a small chunk, then if I have more than one document, I can, for doc in docs, what I can do, I can create a chunk. For that I can call the self dot process document. Here I will be passing the document. Then once I have got the chunks, what I will do, I will create a chunks dot extend. I can pass the chunk. Okay, so once this is done, once the chunks is created, then I can create a vector store. Vector store, that is Chroma dot from document. Let me see, from, yeah, Chroma dot from document. Here I can pass the documents as chunks. Now I can have a embedding as self dot embedding. So this will be our Olama embedding. Now we can check BM25Retriever. I can use BM25Retriever from document. I can pass the document as chunks. Now we will be returning vector store, and we will be returning the BM25. Done. So this is our data injection pipeline. Okay, so let me explain it again. What we have done, we have done few requirement.txt file. Okay, then we have created a data injection pipeline. Here we are specifying the chunk size. Then we have a recursive text splitter, and we have our embedding as PHI3, and this is our injection function, and it will accept a document. I mean, it will accept a path, and we will be loading this using the PyPDF loader. So we are expecting this as a PDF document. Okay, then we will be loading the document. Then based on each document, we will be creating the chunks. For creating the chunks, we will be calling self.process document. So here we have the self.process document, which in which we will do the text splitters. Okay, and here, yeah, text splitters, we will be splitting the document, and we are returning the chunks, and these chunks will be added with the list of chunks, and we are be creating the vector store and BM retriever based on the chunks. So this is the first part of our drag workflow, that is the data injection pipeline. Now we can see our second part. Let me go to our second part. Okay, so this is our second part, that is the QA pipeline. So what is happening in the QA pipeline? We can discuss. In QA pipeline, we are going to use two retrievers, that is the Ensemble retriever, and we are going to use parent document retriever. Okay, so this will give us more accurate result. Okay, that's why we are using the parent document retriever and the Ensemble retriever. So we know that Ensemble retriever, we will have more than one retrievers, right? So in which one retriever, it will be BM25Retriever, and another will be Chroma retriever. So these are the two retrievers that we are going to use, and in actually we will have 2 or 3 retrievers, we can say. Okay, so this is the pipeline, QA pipeline with LangGraph that we are going to implement. So first, what we will do, we will have a starting graph will be there. Then we will create a retriever. The retriever will retrieve few documents based on the Ensemble retrievers and the parent document retriever. Then that will be passed to the generator node. Okay, so generator node generate the result and it will stop. And LangGraph as a property, it will share a state among these nodes, right? So the state will be, so once the retrieve the document, it will update the state, and that will be shared with respect to the generator, and generator will pass that to the LLM model, and LLM model will create a result, final result. Okay, so we'll execute the QA pipeline, or we'll be starting with the QA pipeline. First, what we can do, first we can create a state. For that, I can create a graph state, which is a type of dict. Okay, here we are going to save few things. One is the question, which is a type of string. I can make it empty. Then we have a docs, which is a list, and I can make it as a empty list. I need to have answer. We have a string, and this is the empty string. Okay, so this is a graph state, which means this particular thing, and this will be shared among all the nodes. Okay, now we can start the QA pipeline. Let me add few more things. I can have a class QA pipeline. I can initialize it. So here we will be passing two things. One is vector store of type Chroma, and I can have BM25Retriever, which is in the form of type of BM25Retriever. We have self.vector store, which is equal to vector store, and self.BM25Retriever, which is equal to BM25Retriever. Okay, now here I can set the LLM model. So for the time being, what I am going to do, I am going to create a LLM. To get the LLM, I will be using the Ollama LLM. So I can use the chat Ollama. Chat Ollama, here I will be using model as PHI3. Good. Now we can set our retriever. Set.retriever retriever. Here we will be using the Ensemble retriever. Ensemble retriever can be imported from LangChain. LangChain.retrievers.import Ensemble retriever. Now I can import from LangChain.retrievers.multi-vector. Let me check. It is parent document retriever. Okay, so we have the parent document retriever and we have the Ensemble retriever. As I mentioned, in Ensemble retriever we will have two retrievers. Okay, so retrievers will be, one is vector store dot as retriever. Here we will set the search args as k is equal to 2. Okay, now next is BM25 retriever, and we can set the weight. So for the time being I am going to set the weight as 0.7 and 0.3. Now you guys can try with these parameters. Okay, maybe we can make it 50-50, or I'm going to give 70-30. Now we can have a parent retriever. Self.parent retriever parent document retriever. I can have a vector store. Here we can have a self.vector store. Okay, I can keep a doc store. Here we will be using the in-memory vector store. So for that I need to import in-memory store. This can be imported from langchain.store. I can import in-memory store. Langchain.storage. Let me import in-memory store. Okay, let me come back here. In-memory store. Okay, now we can mention the child splitter. Child splitter will be recursive character text splitter. I can make chunk size as 400 for child and overlap as 10. And here I can make a parent splitter. This is also recursive character text splitter. I can make chunk size as 2000. Can make chunk overlap. It's not overlap, it's a chunk overlap. Chunk overlap, we can set it as a 100. Here also I can make it chunk overlap as 10. Okay, I believe we are good. Okay, so we got all our we got the QA pipeline, initial things of QA pipeline. Now what we are going to do, we need few things, right? I'm going to create a graph. Okay, for that I can create a graph. Here we will have a create graph. The create graph will be using the self, and it will return a graph. Okay, so let me check the chunk size. Recursive character splitter. Okay, we make it. Oh, let me remove this. Let me execute again. Okay, somehow this recursive character splitter, I just copied from here. Okay, maybe this will work. So we can continue. So let me explain what I am going to do next. I am going to create a graph. Okay, so graph will include the retriever and the generator, right? So we can create a LangGraph. For that we need to install the LangGraph. Okay, so let me go to the requirement. Requirement.txt file, I can go here, I can add a LangGraph. LangGraph, and it will be better to add its version also, maybe 0. Let me check on that. LangGraph will be 0.2.60 maybe. Okay, we'll see. Let me double check this one. LangGraph. Okay, it's 0.2.60. So let me add this 0.2.60. Fine. We can run the pip install here. Let me do a pip install. Good. Okay, now let me create a graph here. So for that I can use a create graph. I can pass self, and here I can return a graph. Let me do a pass. So to import the graph, what we need to do, we need to to get the graph, we need to import few things from LangGraph. For that, let me go back here and let me add from LangGraph dot graph. I can import state graph, and I can import the graph, and okay. So we will be passing the graph. So if you guys are not aware of LangChain, I have created a video with respect to LangGraph. So I will share that. I will put that in the comment box. You guys can go and check on that. Okay. So here, let me create a inner function retriever. Okay. So here we will be passing a state. State is the one that is handled by the LangChain. Okay. So from the state, first what I am going to take, I am going to take a question. So this is the state that is shared among all the nodes. So here we will have a question that I am going to get it from here. Okay. So once we have the question, what I am going to do, I am going to execute, I am going to run that query with respect to the retrievers, both of these retrievers. So to make it little bit fast, what I am going to do, I am going to use the concurrent thread function. Okay, for that I can execute the concurrent dot, which is I can import thread pool executor. So I think there is a spelling mistake. RES. Okay. So this will help us to run in a parallel mode. Okay, so this should be equal to, I have fixed that. So let me create a thread pool with respect to that. Can use a thread pool executor as executor. Now results. What we are going to do, we can have a option. What we are going to call is we are going to call the executor.map function. Executor.map Okay, and we are going to execute a lambda function. So based on the each input, we will be calling the get relevant document. And we will be passing the question. So this is the question, and here we will be passing our retriever self dot retriever, then we will be passing self dot parent retriever. Okay, retriever, parent retriever. So what happened is that based on the question, we are executing these things in parallel. Okay, so instead of writing in a simple way like self retriever dot get relevant document dot question. Okay, so for example, here what I can actually do, I can type a self dot retriever dot I can ask get relevant document, right? So in this way I will get relevant document for the ensemble retriever, and I can also call self dot parent document dot get relevant document, right? So in this way I will able to run it in a sequential way. Okay, so to make it little bit faster, I am going to run it in a parallel way, which will give us more faster result. Okay, so this is done. Once this is done, we need to merge all the document content. So I need to have a all docs. What I am going to do, I am going to create a list, then I am going to create a document. So what is happening is that for doc in result 0, so we will be appending, or we will be merging two result 0 and result 1, since we have two results, right? Since we have two retrievers, we will be using 0 and the 0 1. Okay, based on that we will be iterating and we will be getting the document. Now here we will be using doc dot page content, then we will be keeping it as a document. And dot values. Okay, so what actually that we are doing is that we are actually going through each document, each retrievers. Okay, then we will be selecting the document. Okay, then once we have the document, what we will do, we will be taking each doc.page content, we are creating a dictionary to get based on the unique content. If result 0, I mean the BM ensemble retriever or the page parent document retriever, if they return the same page content, then we only need to keep the only one we need to keep. We don't need to keep the duplicate one. So to avoid duplicate one, we are creating a dictionary and we are taking the value of that. So then finally we will get the all unique document. Okay, so once we have the document, so the retrieval process is done, right? So what I can do, I can return the document, all docs. Now I can pass the state. Okay, let me execute this. Here this will be a dictionary. Okay, let me execute this. Okay, fine. So what is actually happening here? We got a state. I mean we got a retriever is got a state, and from the state we got a question, and based on the question we have executed the thread pool, then we removed the duplicate page content, then we are updating the state again. So if you do like this, it will only update. So going back here, so here we have a docs, right? I am only assigning the value to the all docs or the document dictionary. Okay, so rest of the things will not change. So that is why we are doing like this. So once the document is done, or once the retriever is done, what we need next is we need a generator. For that I can create a generate answer. here we also will get a state. Okay, now to get the context, okay, so what we need to do, we need to create a process document. Okay, so we need to create a process retrieved document. Okay, so I will get the retrieved document from the state, right? So this is what we have done here. So here we have updated the all docs, right, in the state. So I will able to get the state, and we need to process this document. Okay, what kind of a process is needed, that we can discuss here. Let me create a process document. Can be a private function, process retrieved documents. Okay, here I can pass the document. Now I can return a string. So what I will do, I'm just embedding everything. I'm just merging everything with respect to /n. I'm going to join docs. What I can do, I can have a page content here, doc.page content. Okay, so we will make, so instead of document, what we are going to do, we are taking the document, we are looping through the document, and we are taking the page content, and which will be joined using /n, and finally we will return it as a string. So here we will get the context. Okay, now I'm going to create a prompt. So what is my prompt? Can have a prompt within this. I'm going to tell answer the question based on the following context. So the context will be, context is the one that we are going to pass the context, and we need to have a question. The question, we will get question from the state, right? State, we have the question. Okay, then you need to tell me the answer for that. Okay, so this is our prompt. Okay, so once the prompt is ready, okay, we need to create a LLM model, and we need to trigger an LLM model for that. So before that, let me make one more import, that is from LangChain core. I need to import LangChain core dot messages. I need to import human message. Okay, now let me come back here. I can add that here. Messages, I am keeping a human message, and I am keeping a content. Okay, content which is equal to the prompt. So the message is ready. Okay, now I can have the result. For the result, what I can do, I can use self.llm.invoke. I can pass the message. So this will actually return the result. Okay, so for that I can return, similar to earlier that we have done, I can update the state. For that I can have the answer will be result, then this will be the state, rest of the state will not change. Okay, so we have our generator, is ready, and we have our retriever is ready. Now we can go and create the graph. For that we can have a workflow. I can use a state graph. Graph state can be sent. Here I can add a node. Here I can say retriever. Then one node will be the retriever. then workflow dot add node, add underscore node. This will be the generator, and this function will be generate answer. Okay, so we have our nodes are ready. Now we need to link these nodes. For that I can add a workflow dot set entry point. So our entry point will be retrieve. Now I can set add edge. From the retrieve I need to go to the generator. Okay, from generator I am going to finish the workflow. Workflow dot set finish point. My finish point will be generator. Okay, now we can compile the graph. Graph can be workflow.compile. Here we will be compile the graph, and I can return the graph. Okay, so let me execute. So we have done with our QA pipeline. So in QA pipeline we are using two retrievers. Okay, then we are creating a retriever function which will retrieve the document based on these two retrievers. So we are using the thread pool executor here to get to execute it parallelly. Okay, now we are going to create then we have created a generator will accept the document, and which will process and will create a prompt and will do a execution. So once that is done, here we have created a graph, a state graph, which starting point as a retriever and the ending point as a generator. Then we are returning the graph. Now we can will able to call this graph. Okay, so we can do the next part. So in this, what we are going to do, we are going to create a data injection pipeline. Okay, then we are going to create a object of QA pipeline. So for that, first let me go and create a data injection object. Okay, here I can have a data injection object which will be data injection pipeline. I can say instead of data injection only, I can say the data injection pipeline. Okay, the object is ready. Now we need to have a path has to be set. Okay, so this will be my document path. Dot path will be, so I have copied a document file here. So this is a HR policy document. Okay, this is available in online, so I just use this one, and this is my path. Okay, so I will show you what is in this document, and I'm going to call the data injection dot inject method. So that will actually return a vector store and a BM25 retriever. Okay, data injection pipeline dot inject. Okay, I'm going to pass this path is equal to document path. Okay, so once let me execute this. Okay, so we are getting bunch of errors. We'll see. Chunk overlap, unexpected keyword, chunk overlap. Here chunk overlap, spelling mistake. Done. Executing. Okay, so we need to install the PyPDF also. So let me have the PyPDF. Copy PyPDF, and I need to check the version of PyPDF. PyPDF version. Here the version is 5.1.0. So this is 5.1.0. We can run the pip install. So let me do a pip install. Okay, installation is done. Go back here. Let me try again. This time it seems to be working fine. We'll wait. Okay, in between I will show you what is there in this document. So let me open this. Okay, so this generates me HR purchase and leasing. So this is available in online. So I just copied that. Here they are mentioning about the timing and some of the leave policies, etc. Okay, so let me make it open. So we are done with our data ingestion pipeline. Okay, now what we are going to do, we are going to create a QA pipeline. So here I can pass a QA pipeline. QA pipeline required two things: vector store and it need a BM25 retriever. Okay, so we'll see. Ensemble retriever has a should be runnable. Input should be getting another error. You can go and check this. Ensemble retriever retrievers as retriever. This should be okay. So here we have mentioned it as a object, but this should be, I mean, a class, but this should be an object, right? So I must be using self dot. I should be using self dot BM25 retriever. Okay, we are solving our errors one by one. So we got our QA pipeline. Okay, so once we have our QA pipeline, we need to get the graph, right? So for that I can have a call a graph can be get it from QA pipeline dot create graph. We call it here. Also we are getting entry point at that is one at start. So let me go there, set entry point. Okay, so this should be retriever, not retrieve, and retriever should be okay. Should be a minor mistake, I believe should be corrected by now. Now we need to have a QA file. Let me create a graph. Good. So we have got our graph also. Now I am going to invoke the graph. My result, I am going to graph.invoke. I can pass a query here. So my question will be I can say what is office timing. Let me execute this. We'll see. Retriever ID during the task with a name ID. Okay, here we have an error. Let me check this. So it says list. Here we have a doc is there. This should be like this. Okay, so executed. Now executed. Let me execute it again. Okay, so data ingestion pipeline is in progress. Again we are getting an error. Let me check this. QA pipeline object new attribute process retrieved document. QA pipeline process retrieved documents. Okay, let me execute again. QA pipeline, we have a graph and graph.invoke. Okay, start running. This may take some time because we are actually using Olama PHI3 and which is actually running in the CPU machine. Okay, that is why I think that may be the reason it is taking some time. Anyway, we'll see. Okay, so the execution is done. We can check the result. The result said answer. The working hours at the office is 9:30 a.m. to 5:30 p.m. So let me copy this, or we can have a result dot answer. So this is the answer. Maybe I can take a content also. Okay, let it be like this. Message dot content. Okay, let me copy this, paste it here. Okay, so it says the working hours at the office are from 9:30 a.m. to 5:30 p.m. with a lunch break taken by the staff in turn lasting for an hour, about an hour, and the 30 minutes without affecting the customer service. The biometric punching should be done promptly within this timing or as late as up to 10 minutes past 10 if unforeseen reasons arise, though such instances requires the compensation of. So this seems to be correct. And if you look on this, if you look on the PDF, we can say that this seems to be correct, right? Office hours is 9:30 p.m. and lunch break is 30 minutes, and it's explained everything in correct details. So we'll see one more thing. So before closing this this tutorial, I need to show you one more thing. Okay. So one small change that I'm going to make, instead of chat models, I'm going to use LangChain OpenAI model. So for that, I need to install OpenAI also. Let me import. So let me install that OpenAI. LangChain OpenAI. So let me check its version also. You can check LangChain OpenAI. So this is the version that we can use. So let me copy this. Paste it here. I'm going to execute. Okay, so the execution is done. So let me make one small change here from LangChain import chat. It will be why the chat is not working. So this can be chat LLM. Okay, I need to check this. Let me try this. Import chat. So autocomplete is not working. That is the main problem. So let me check this. Second. Okay, so here I have imported from the LangChain OpenAI. So we need to import the chat OpenAI, and I have done few other things also. So I have added one more thing. Python.env is added, and this is actually loaded here. So python.env, and I mean from .env import load .env, then I am loading the env file. So this will help us to load the env file, and within the env file I have a Python, I have the OpenAI API keys there. So this is also like we discussed in our previous videos. Okay. So once that is done, what I am going to do, I am going to make one small change in the QA retriever. Okay. So in the QA retriever, instead of llama, instead of olama, I am going to use self.llm. I am going to use the chat OpenAI. I am going to use model as maybe GPT, maybe GPT-4 or mini can be used. So this is my model. So I have executed that. So last time when we used the Olama PHI3, then we got, it took like 27 seconds, right? So we'll see how much time it will take when we use the OpenAI. So execution is in progress. Okay. So this time it took only 6 seconds only. Okay. So this also further we can improve, but 6 seconds is good for now. So for the time being, I will keep chat Olama because that is free, and OpenAI we have to pay some amount, right? So we have done with this project. So let me go through again what all things that we have done. We have created a chat data injection pipeline, then we have created a QA pipeline, and we created a graph state. Okay. Then within the QA pipeline, we have created a retriever and generated, and we have created a graph. So based off the graph, like we will able to ask some queries with respect to the uploaded document. So here we are using the HR policy DHLL.pdf file. So this is openly available from the internet, so I just took it. So it seems to be things are working fine. So I will upload this into the GitHub, and we'll see how can we build a REST API with REST API on above this. Okay. So that's it. Please do like and subscribe. Have a nice day. Bye bye.